Okay, good morning everybody. It is, I guess it's Friday. Wow, 12/4. Well, one more day closer to summer, I guess, huh? Okay, today, similar polygons. So similar polygons, funny word, but similar is going to mean same shape. Same shape. But maybe different size. Same shape, but maybe different size. So if they have the same shape, then one of the things we know is that the angles are still going to be equal. Same shape, right? But the sides are different sizes. So this triangle is bigger than this triangle, right? So what they do is we talk about some kind of a ratio. So what we know about a ratio is a fraction. And we can find the ratio by setting up the fractions. So if I want to find the ratio between triangle IRS to triangle S or ZXY, I would say, well, it's the same thing as 25 to 15, because those sides go together, don't they? They're corresponding sides. Or I can go 20 to 12, because those two sides are corresponding sides. Or I can go, my 30 goes to 18 because these two are corresponding sides. Now if I reduce these fractions, let's reduce these, okay? Let's reduce my fractions. And of course you guys all know how to reduce fractions, of course you do. Divide by 5, and I get 5/3. Divide by 4, and I get 5/3. Divide by 6, and I get 5/3. So what's my ratio? My ratio is 5/3. And because the ratio is the same between all of the corresponding sides, then these two triangles are similar. So we write this. This is our symbol for similar. Okay, that's my symbol for similar. Don't say equal because these two triangles are not equal, but they're similar. They're the same shape, different size. So we'll say triangle IRS. Write this down. Triangle IRS. Oh, shoot. Oh, you keep getting me when I'm recording. Can I call you back? Sorry. So triangle IRS is similar to triangle ZXY. Now you got to make sure the angles that go together go together. So I'm going to go I goes to Z. This is really important. And of course, angle R goes to angle X because those are equal. And angle S goes to angle Y because those are equal. Okay? So I'm going to write triangle IRS is similar, that's my symbol, to triangle ZXY. Okay? Now, corresponding angles. Well, we know this, that angle I then is congruent or equal to angle S. I'm going to mark that. Angle Z. I'm going to mark that. So this angle is congruent to that angle. Okay? I also know that angle R is congruent to angle X. So I'm going to mark that, but a different mark because of different angles, right? And then finally, I can write that angle S is congruent to angle Y. And I can mark that too. But I'll do a different marking because they're different angles, okay? So now we know that if figures are similar, then their corresponding angles are equal. So, I don't know, maybe let's say this is maybe, I don't know, say 40 degrees. This would be 40 degrees. Let's say this is 80 degrees. That's 80 degrees. Let's see, that means this would have to be 60 because that's like 120. So it'd have to be 60 and 60, okay? Now the sides are not equal. They're not equal. In fact, 20, 12, 25, but they are corresponding. So we can say that IR, side IR over ZX is equal to, RS over xy, sorry, rs over xy, which is also equal to this proportion, is to zy. And we already know what the proportion is. We just did it above. The ratio is 5/3 to 5/3 to 5/3. So this triangle is 5/3 as big as this triangle. Or the side's 3/5 of this triangle. Okay, so far so good. So a couple of things. Similar triangles, or similar figures, same shape, different size. They have a ratio for their sides, and their angles must be equal. Okay, let's turn the page. So on the back side, we have an example. So here's what we need to know. We need to know that the two triangles are similar. So we need to be given this. We need to be given this information. That triangle, EDF, is similar, not equal, triangle, now we've got to be right, EDF NMP to NMP. So if they are similar, then we can set up the ratios. Well, I got 15 to 18, I got 20 to 24, and I can also set up x to 30. So I can set up these ratios. I can say, okay, 15 goes to 18, as 20 goes to 24, as x goes to 30. Now, I just need to find x. So let's just make it easy. I mean, I've got two equal signs. Let's just look at this, okay, because they're equal, right? And so if I say 20 goes to 24 as x goes to 30, and set up a little fraction, I can cross multiply and solve. So what I'm going to do is, to solve for x, let's multiply by 30 both sides. So I'll multiply by 30, and I'll multiply this by 30, right, because that'll cancel that out. I just want to find the value of x. X is equal to, let's see, what is 20 times 30 is 600, but we'll go 20 times 30, and we'll divide that by 24, right? Just use my calculator, and what do I get? 25, and that is the value of x, which means that is the length of EF, which is going to be 25. Okay, hopefully you guys are getting it. So if they are similar, you can set up proportions to solve for missing side. You set up fractions, this to this, this to this, this to this. Okay. Okay. Now, last example. So we're given they're similar, and it seems like this one's half the size. Okay. So we know that the area of triangle ABC, we don't know everything, but we do know the area is 36. The area is 36. So does that mean the area of this one would be, looks like the ratio is half, right? Goes from 10 to 5. Looks like the ratio is half. But I think we realized yesterday, and you guys helped me out on this, that just because the ratio is 1/2, that's to the sides, but the area is going to be 1/4 of that. The area should be 1/4 because we changed the base and the height. So if the area of this is 36, the area of this one is 1/4 of that 36, which is 9. Okay, that's a little bit harder. Okay, and you can set up the ratio between areas. You know, it's 1/4, so I can go the area of the big triangle or the area of the little triangle is an area of 4 to 1. And if you solve, you get 36 equals 4 times the triangle, and you will divide, and you'll get 9. Okay, that's what I have, and we'll talk about this again in our Zoom. Okay, have a great weekend, you guys.